And we're back again. That music.
Once again. It's almost like we do this every week.
I know, right? Just imagine that. And imagine if I can get my microphone in the right place, right? There you go.
Yeah, we can hear you for once.
Shock. Anyway, how is everyone? Hopefully everyone's having a great time. And we're back.
I guess I'm everyone. Week. So I'm doing great.
No, I mean, everyone watching. Come on. Right. We're back for this chapter, Chopper and Streams, chapters 12 and 14. We will be back for 13. Either we did that last one or we're doing it the next one. There's some flip around.
13's my lucky number, so I'm waiting for it.
There's some flip around with the chapters at the moment. So check out the playlist. The playlist has the most recent updates on it, so you won't get lost. Right. I think we have an Esra in the background. Esra.
We do.
Welcome to the stream.
Hi, everybody. I think we also have Danielle.
Danielle. Do I have a Danielle? There we go.
Yeah. We do. I'm back this week. Sorry for missing you last week, everybody, but hey, I'm back.
That's all right.
And for all of our American people, happy Thanksgiving. That's our holiday tomorrow.
Yes, tomorrow, right? Yeah.
Happy crazy packing tonight and travel tomorrow and dealing with relatives.
I'm heading to the Keys to enjoy a restful weekend of playing around with dolphins and.
Are you going to be able to get back? Because last time you flew, you were having some trouble with flights.
No. And that was a lot of fun. That's right. Yes, I'm not flying this time. This time I can drive. So even though they're islands, I can drive to them because there's a bunch of bridges.
Right.
Well, I just call that an unplanned vacation in a random place.
Exactly. So well. All right. Should we take over and start doing the stuff?
Yeah. We're going to get out of your way, and we'll leave it to you guys.
Great. We look forward to that. All right.
We'll carry on with that in a second. Don't worry, Scott. Yep. So we'll see you in a minute.
Okay. Great. Thanks.
Okay.
All right. So we've got it. We've still, even though it's a holiday here, and a lot of people aren't able to be here live. Like Craig's not here live, but he recorded videos for us. So we'll be able to watch those fine. And we've still got the authors here. Stef's here. Why don't we bring Stef on? Hi, Stefan. You are muted, by the way. Just to let you know. You're still muted. Okay, that must be on purpose. All right.
Yes, it was on purpose. Hi. Missed you guys.
Great, welcome. And we will look forward to coming through with that. Let's go ahead and bring up our welcome slides if we can.
Yes, so we can start by saying, okay, welcome everybody. So let's start with why we are here today. And with Flutter Apprentice Book Club, this stream will be about chapters and streams, which are chapters 12 and 30. So let's bring it up. I think next we have do's and don'ts for this stream. So maybe we can go here. You want to go over, Danielle?
Yeah, absolutely. I can do that. Okay, so we have this is the worldwide internet's here, and we have some do's and don'ts. And so basically, what we're saying is you need to be nice and respectful and constructive when you're interacting with us at all, but definitely today on the YouTube live chats. If it's adult, if it's rude or offensive, not safe for work, please just don't post it. We also, this is not a place to advertise or promote things. So ask your questions. You can give us encouragement and stuff, but don't advertise or promote stuff. And one thing people sometimes do is they'll post the same question over and over and over. And if you do that, that's not a cool thing. And it actually makes us less likely to answer your question. And then finally, and I hate that we still have to say this in 2021, but harassment of any kind is not tolerated. And if you do, we will kick you off. And the Flutter community is amazing, but it's also small. So we definitely talk to other people. So just be nice, treat us all respectfully, and that's our do's and don'ts.
Okay, so that's what only we are asking for you to do anyway. So now maybe we can go for introducing our people here. Craig couldn't make it for today. So Sarah also, but maybe we can start with Stef.
Hi, I'm Stephanie Patterson, and I am here in multiple I can't think of the word. Oh my gosh.
Capacity.
Thank you. Capacity. I am with Esra and Danielle, co-manager of the Flutteristas, which is a Flutter community for women and non-binary with a passion for Flutter. And I am also the tech editor for RayWenderlich.com's Flutter Apprentice, the whole reason we're here. Wow, I'm really struggling this morning. Sorry. And we have Kevin, who is the author for the chapters that we're doing. If we can bring him on and let him introduce himself.
Hello, everyone. Hi there, I'm Kevin Moore. I'm one of the authors, one of three. So I wrote this chapters on what we're talking about today.
Thanks for being here.
And I'm sure you'll join us for the Q&A, so thank you for that.
Yeah, thank you so much for joining us today, Kevin. We are really excited to have you here again. And we have Sarah in the backstage. She's the Flutter Community Program Manager. She's helping out Nilay, if you know, and she's the driving force behind us. So thank you, Sarah, for helping us. And I think Randall, our question hero, couldn't make it for today.
Well, yeah, but we still take questions.
Yeah.
It's just, yeah, the behind the scenes question guy is not actually going to be helping us. And yes, and that's the next thing I was about to say is when you ask a question, put a Q in front of it. That helps us identify it. And that helps a lot so that we can know, when we're looking at it, we can see it, helps us find it better when we try to put you up on the screen with the questions. So that's definitely it. Yeah. And now I think we've got some resources, and let's go ahead and bring Sarah on. And I've got to admit, she's got one of the most unique virtual backgrounds I've ever seen today. So. You're muted, Sarah. There you
Thanks.
go.
Yeah, I'm here, and I just wanted to say that since Randall can't be here, I'll be writing down your questions and passing it on to our wonderful hosts and panelists. So let's get started.
Yes.
Well, this is one of the ways that we've got right now to help new people with Flutter or people even that are experienced that have questions. And I think we have resources that Sarah has kind of gathered together to tell us about.
Okay.
So
yeah, sure.
I think you need to scroll the page.
Do that now. If you want to go to the next page.
Okay. Let's go for community resources. And you can just ping me, Sarah, to go for the next page.
Yeah. Well, the Flutter community is amazing. It's really special. And part of what makes it special is there are so many friendly people that want to help you. So if you can go to the next slide. Can you go to the next slide? So one of the best places to get help is by joining a local Flutter meetup. There are currently 112. I actually think the number's higher, and this is a little out of date, groups around the world in 58 countries. And more are joining every day that are just full of enthusiastic, passionate community members that want to share their love of Flutter. And often it's full of people that have like specialty knowledge. So maybe you're really good at, I don't know, animations, but then another person is really good at architecture. So you can sort of put your heads together and learn from each other. And you can go to talks and workshops, and it's just a really nice place to go get help. So you can go to the links in the show notes about the Meetup Pro Network and try and find one near you. And because of COVID, there's been a really great renaissance of online events in the past year and a half. So even if there isn't actually one new year, there's a good chance that there's one in the same region as you, the same country as you, that it might be in your local language, hosting online events and has some kind of online community as well. So you can try and check that out. But if meeting other people in real life is not your thing, It's not everybody's thing. There are lots of great online resources. So can you go to the next slide, Ezra? Yeah, so this show right now is about the Flutter Apprentice book from Ray Wenderlich. So a really good place to get help is the Ray Wenderlich book forum, which is where other people that are currently taking advantage of this offer are reading the book at the moment. And so maybe they're asking the same questions. There's also Stack Overflow, where there's a lot of really classic questions that have been answered already, and then new questions are being answered every day. It's an active community there. And then there's the Flutter Dev Reddit, which is also very active, and you can meet other community members there. And then, of course, the Flutter Community Slack. I can't remember, last time we checked, it was like 15,000 or something. It's a huge community now, and there's lots of people there that want to help you. There's also the Flutter Discord. And finally, of course, there's Here, where we answer your questions live every week. So the links to all of these are in the show notes, so you can click on the links easily there to check out the different resources. So if you get stuck, which everyone does, everyone gets stuck, don't worry about it, then there are places to help you get unstuck. So take advantage of them. That's it. That's all for me.
Great, thanks, Sarah. I appreciate that. And I hope you get your background fixed soon. And all right, well, I think that's probably about what we have going. Like I said, Craig can't be here. He's away celebrating Thanksgiving, but he did record videos for us. And I think it's probably time for that. So if we could play that. And I guess before we start that,
all right, everyone, welcome back to the...
I'm sorry. I was going to say I've been watching our comments. We're seeing questions come in. Remember, put a Q in front of the questions, and you know, I wanted to give a shout out to the people that are in there interacting with us. So now if we could play Craig's video, I'm sorry.
All right, everyone, welcome back to the Flutter Apprentice Book Club. This is week, I've lost all track of what week it is. It's one of the weeks, and we're covering Chopper, which was chapter 12 in the book. This is a continuation of where we left off last week, where we finally implemented an API source in our data layer, and this allowed us to delete from our project entirely that mock APOD API source and those JSON files that we had been using to load data. So our app got real. We started to see updated pictures from of various days from NASA's API. That was exciting. But we hand-rolled our HTTP integration, and there were some sneaky issues with it. And Chopper is a library that is going to help get us kind of, it's like bumper bowling, you know? As soon as you try to write some code that's a little too ridiculous, Chopper is like, that's not where I want you to write that code, and kind of course corrects you back on track. So let's get into it. First, we are going to examine a little bit more about why. We're going to dive deeper into what I was just saying. Why do we want to use Chopper? And then we'll look at what Chopper is, and then we'll use it. Pretty straightforward there. Okay, why do we need Chopper? The app was working perfectly fine at the end of last week. Well, it was working perfectly fine for now, until we come back later and start refactoring things and forget some of our earlier assumptions. So let's look at these two URLs that we hit on the NASA APOD API. And you can see right away that they have the same base URL, and they're only differentiated by query strings. Okay, keep that in mind. Also note that if we put in the date query string, the NASA API actually returns just one dictionary. And if we put in the start date and end date, it returns a list. And never mind the fact that even returning a list is technically malformed JSON. You know, the pirate's code is more like guidelines. So the we've got different deserialization logic based on the same URL, just on query parameters. So this is interesting. And we did have to juggle this in the last episode. And we juggled it with these two methods. Remember, we settled on having a list method and a detail method. And you can see there are different return types. List returns a list of the map string dynamic, whereas detail just returns a map string dynamic, not wrapped in a list. Okay, seems reasonable. And they both accept this apod request parameters class. And that was what had one field for each possible query string. But this implementation creates the possibility for a rather awkward mistake. And that mistake would be if we wrote this code. Imagine we tried to await our apod API's detail method, and we passed in the apod request parameters object with start and end date values. That would put us back in this bottom URL, which is the list URL. But we've called detail. And what detail implies is how we're going to deserialize this response. That we're going to expect to encounter just one map, one object as the response, but we're going to get a list. And what's, excuse me, what's most insidious about this type of error is that the way we've coded everything up, it's just a runtime error. There's no way for the linter to help us with this. So Chopper is there to the rescue. Chopper can help us with this. Also the inverse. We could pass the detail situation to the list method. This will be a similarly problematic runtime error. But there's more. There's more reasons even beyond that to use Chopper. This was the method that both list and detail ultimately routed through in our implementation of the apod API. And we can see that it was just forwarding along whatever apod request parameters object it got. And then we've got these lines of code where we set everything up, make the request. It's a little hard to read here, so let's look at it again with some comments. Same code, just with some helpful comments. And we're making, we prepare the request, we make the request, and then we make sense of the response. That's the code that we wrote. And it worked just fine. But what if we wanted to write a test for this prepare request block of code? That test, as we've currently written things, would need to then go on and make an HTTP request to the URL. And then it would decode the response. Okay. This is a bad test. Your test suite will be very slow and APIs will be very tired of you for hammering them pointlessly. So this is not good, right? This method that we wrote, and it technically worked, and it kind of seemed fine, it's going to be more or less impossible to test. Note, by the way, we would want to test at some point this top block and the bottom block, but you wouldn't actually test this middle block. That's up to the HTTP library. It's its job to make sure that the get method works. So you wouldn't really test this because the HTTP library has got your back for that. But we would definitely want to test any of the non-trivial code that we write. So that's trivial code that we wrote in the middle, actually make the request. Non-trivial code is at the top and the bottom. We'd want to test those, but they're sitting right next to an actual network request. So not great. So Chopper, I've said, and if you read chapter 12 already, then you saw it in action a little bit, can kind of tidy this up. So we have a computer and a server sitting there. It's classic internet stuff, just doing internet things. And the computer wants to make a request to the server, and the server lives to make responses, so it wants to do this as well. Great. But in our code, there was a lot of boilerplate, things like adding the API key to every single request. And, there's all this stuff. I didn't really know how to represent it on the slides, but you can imagine more gobbledygook in the response part for the unpacking of the data. And there's just a lot of stuff that needs to happen every single time when you send the request and when you get the response back. And putting those things in the right spot, we've already demonstrated, isn't necessarily easy or obvious. And so what Chopper is going to do for us is offer these different classes, and they call them interceptors and converters. They do slightly different things. And they're going to give us discrete, focused places to write some code that does very explicit jobs. And we'll see these jobs momentarily. And they'll be nice and testable as well. And then the same thing for making sense of the response. There's more interceptors, converters, and then also a new player enters the arena on that end, error converters, because you can get back, as we saw last week when we talked about HTTP status codes, you can get back those dreaded 400 or 500 responses, and then you have an error on your hands you have to make sense of. Okay, so let's look at some code. I'm going to pop over, I'm going to zoom out, and all right. So the first thing that we did, I'll open up pubspec.yaml, was add Chopper. So easy peasy here. Chopper appears in the dependency section, and then Chopper has some code generation. So there's another dependency, Chopper generator, that goes down in dev dependencies. And it's nice to put any of your dependencies that do the actual generation in the dev dependencies block, because you don't need, there's a whole lot of code that makes sense of these terse little annotations and then figures out what code to write, and none of that needs to actually ship with your app to people's phones. Just the code that was generated gets shipped. So dev dependencies are things that get installed when you're building your app, but don't actually ship with the final app. And none of this build runner, Chopper generator, the linting code. Interestingly, freezed is down here, and that's because the author of this package, who's also the author of Provider and many other things, put all of their juicy logic in the package called freezed. And then all we need to go in the actual app was this annotation package, and it has almost nothing in it. It just activates freezed during the development cycle. So that's how that one works. But it's the same situation here. Chopper has the juicy bits of Chopper that do all that heavy lifting are in a sibling package called Chopper generator. Okay, moving on. Apod API, already got the file up. Now, this starts to look very different than it looked last week, which is good because we just got done talking about how not ideal our implementation was last week. And we still have our two methods, list in detail, but look at this. We already have some interesting changes. They're each just taking the appropriate variables, parameters, and we're obviously going to convert them into query strings. Now, there's some really kind of odd syntax here, reminiscent of when we were writing code for freezed and JSON serializable, this like random @get thing, Chopper API sitting up here. This is just kind of the state of code generation in Dart right now. These classes help us out a lot, and they generate a lot, and they just ask from us, can you, it's almost like marking the thing, can you put this like weird X on this spot, and then I'll know that I need to like take care of it. And so we kind of have to help out the code generation packages. So this says the whole class is going to be decorated. This says this function is going to have a certain detail to it. And that detail is that it's a get request as opposed to post, put, update, or patch, or whatever they all are. And we've got some more code generation helpers here. This query decorator. This isn't the kind of code that you very often write in vanilla Dart. This kind of stuff only shows up if you're writing code to, lay down all the bits of information that a code generation package will need. But we've got our list in detail methods here. They're looking pretty good. And we're looking at code right now that we hand wrote. So this is not generated yet. So we wrote all of this. And then we have add query. This one's straight out of the book. And we're just putting our API key into the query parameter. So let's look at this function signature here. It takes a request and it returns a request. So it's either modifying the existing request or copying it with some changes and returning the copy, whatever. In our case, it's obviously copying, as we can see right here. But that's what's going on in all of these methods here. We've got another one down here, Flattened Dates. And this one's important because we actually took date times in our method. That's the easiest thing to think about in our Dart code, is that I want to know the pictures of the day for these certain date ranges. So I want to think about it in terms of date times. But a Dart date time is very specific to like the internet. And the query parameters all have to be strings. Just there's no ifs, ands, or buts about it. So it's going to be flattened dates that will handle that for us by just checking whether or not each date is in existence and is a date time, and then changing it into the date string. And we wrote this date string method ourselves. And then a similar, we take the request and we copy it, but we alter the parameters. And we set those parameters to be our new parameters. And so this is the same method function. Takes a request, returns a request. Okay. And then we got down here, and this is where we actually kind of stitch everything together, all straight out of the book, out of your tooltip. We make a chopper client, and our add query and flattened date methods show up. And these are interceptors. So they get to kind of put their grimy paws on each request on its way out the door. And that's actually extremely helpful for us. Converters and error converters are a little different, and we'll see what they do as well. So actually, I guess it's basically time to just look at the converter, isn't it? A lot of this code, again, straight out of the book. Convert requests. So this applies some headers for us, the content type header, and we set it to be JSON. So if you're not familiar with HTTP headers, don't worry about this a ton. One day it'll be good to kind of point your brain at HTTP headers a little bit, but today doesn't need to be that day. Encode Json. So this basically takes all of our proper Dart objects that we're thinking about on the way out the door and converts them into a string right here. And this again is helpful because everything has to be a string. Decode JSON, this is for stuff coming back to us from the server. Now we're thinking in parse the response land here. Notice that this code is separate from when we make the request. We haven't even seen where the request gets made yet. We will shortly. But all of this code about making sense of the response is separated. And all the code that we were looking at earlier, like these methods, look how testable this will be. It just takes a request and returns a request. Actually, it'd be a little untestable because I put underscores here. I kind of add query, this was from the book, and then I wasn't really thinking about it and kept that going. To write a test for this add query method, we have to get rid of that underscore. But then it's very testable, which is really important. But back in our decode JSON method, this is a lot of stuff that we saw before, where we actually have a little redundancy here I think I got rid of this later, but I'm copying over the date into the ID spot. This is if it's a map, the response that we got back from the server. Let's actually look at all of these things. Looking at some headers. Okay, not too concerned about that. And then if we conclude that it should be JSON via the headers, then great. Actually, this is funny. This line is just UTF-8 decoding, and we don't do JSON decoding until down here. So I've written a little code here. It doesn't make much sense. Apologies. I'm only realizing that now. But we are getting back, basically what matters is this line where we decode the ones and zeros in the response. Because remember, strings are just a way to interpret some ones and zeros. So we're saying, yes, these ones and zeros are strings. Think about them in this way now. And so we're getting UTF-8, which is an encoding for strings back. That's our body. And then we say, hey, we got that string. Maybe it's valid JSON. And this, it might not be. That's why we have this try block here. But then we've got the actual response from the server in our hands as some JSON. Well, as like a Python object, whatever JSON to code turned it into. So then we say, well, hey, maybe it's a map. And if it's a map, then we assume that they called the detail method. So we can know that we're just dealing with a single object. And so we copy over all of our stuff here, or the date into the ID field. This harkens back to the last section. And then ultimately, that we use the same kind of response, success and error thing from the book. I'm a big fan of that pattern myself. And last week we talked about potentially using some functional patterns with either the darts or I forget the other ones, libraries. So this is, right in that space. And what was the name of that result? Yeah. So this code right out of the book. I don't think I changed a character here. We've got a result class, and then it can either be a success or an error. And this actually is pretty valuable, pretty helpful stuff. So we're not doing a ton of error checking here, so we just assume success, and that's why this is showing up here. And then what is the object that goes into that success? Well, we're going to turn that JSON back into an APOD instance, and then it's finally going to return to the rest of our code as an APOD instance, which is great. But what if it wasn't a map? Well, then it was probably a list, and then we assume they call the list method. So, okay, very, very similar, except we're looping over the code at this point. We're looping over the response, sorry. But it's the same thing. It's just this code in a loop, essentially. And the map method is where that loop is coming from. And then finally, if it wasn't a map or a list, then we do actually have an error. Then we were going to return our response, but we changed the body to be this error instead of the success. So that's the APOD converter. And this, again, there's a lot going on here, but it's all for the task of making sense of the response. We don't make the response. We're not preparing the request. Sorry, make the request, I meant to say. We don't prepare the request. We don't make the request. This function got a lot going on, but it is only making sense of the response. So that is going to be a lot more testable as well. And then the last thing I wanted to point out in this step was the generated code. With freezed and JSON serializable, actually JSON serializable we looked at as well. Freezed I described as being unfit for human consumption. But luckily, Chopper is also actually pretty agreeable, the generated code, which is great. So if we look at what's going on here, it generated a list method for us. And there is some of this kind of wonkiness happening again, where it's like this, a whole new generated class with a class name that kind of looks weird, but oh well. Chopper makes all of this kind of come together nicely for us. But this list method, this function signature came from our handwritten definition. How did it know what to write there? Because we basically told it everything that it needed here. And that list method with the two parameters, start and end date, appear here, list, start date, end date, good. So what is this doing internally? Well, it's this empty URL variable is coming from the fact that I didn't pass anything to the get decorator. So it says, all right, there's no special URL that we put on the end of the base URL. Remember, this is the base URL. And it's true, there's nothing we need to add on to this. This is the whole thing. So, okay, don't add anything onto that URL because that's just how the NASA API is set up. They could have set it up differently. And then we'll grab all of our query parameters together. And this code is, generated. We didn't have to hand write grabbing each of these things. We didn't have to worry about forgetting one of them. Assemble the request object. And this kind of has, all of this code makes sense. It's a GET request, the URL, the base URL, and then any parameters. This all makes a lot of sense. And then we do this client.send thing. And that's where it all happens. That's where our interceptors and converters start to be able to do their thing. Detail request down here, exact same thing. The only difference is that it's date instead of the other query parameters. So that's how Chopper works. With this, you have a functioning Chopper implementation. And one thing I want to point out, though, if you follow me on Twitter, you might have seen during the last week that I was stuck on how to actually do this stuff. I was writing some code that needed to be in an interceptor in a converter instead. How could I, right? But it was, I mean, I was genuinely stuck. I spent an entire afternoon, had no idea, tweeted about how stuck I was, and got help from people in the community. Someone downloaded the code, looked at it, and spotted the place where I had, what I had overlooked. And so when we talk about, by the way, asking questions, it's okay to not know what's going on. There's a community there ready to help, like literally doing the same thing. So don't feel bad about needing to ask questions. Okay, I'm going to now do git checkout chapter 12, step 2. There's only 2 steps this time. And the second step is to use the new Apod API. So we'll load API source, because based on how we've been breaking things up before, we sure do hope that this will be the only file that changes. So in our API source, it still takes an Apod API. That is standard from before. But these methods are now get item. They're just a little different. We're calling API.detail, just like we were before, but now we just get to pass in the exact parameter that we want. And then for our response, admittedly, this code is a little bit, this code's a little wild. But we say, we first check, is the body a success? Remember, this is that success error switch coming back from result. And we know we're getting a result in our response bodies, and that result is actually either going to be a success or an error. So we say, hey, is the body a success? If it is, then we'll recast it as a success. We know it's not null, so we can do the exclamation point unpacking of null safety. So we'll recast it as a success with an Apod generic type. And then that opens up .value to be available to us, because success, I don't know why I keep closing the result class, I keep going back to it, has a value variable, and it's of type T. Okay, got it. And T is the same that we have here, all the same. So, but we know success is holding an Apod, so we grab the value parameter. We remind everyone, hey, it's not just Apod, like we said here, it's actually also T. And this basically just says, darn, Apod and T are the same. And that's what we're able to return. So finally, we get back our future of type T. And T can be null, but in this case, it isn't. It is, of course, null in the error case, where right now I'm just printing the error. This is really incomplete error checking. Our UI will just hang, which is not what we want. All right, and that's it. I mean, get items, sorry, same thing. It just has the other variables. And then it's the same kind of code, except it's a list instead of, it's a list of T instead of T. So not too bad there. And folks, I hope Chopper seemed like it helped kind of clarify our code, and it helped us break it apart into some testable chunks. But let's pass it back to everybody for questions, and then we'll see you back shortly for chapter 14 on streams.
Hello, everybody. All
Hi,
right,
everybody.
that was an awesome chapter.
Absolutely
So,
was. Absolutely.
If you have questions, to help us find your question, please do not forget the Q in front of it so we can find it easily, and we will read and answer them as possible right now. So maybe you can hop up to the stage.
Absolutely, yes. Definitely put a Q in front of them, and I'm looking forward to that. It seems a little bit of a quiet day for it, so please come on in and ask them. And to help answer the questions, we've got Simon, who is our own resident expert, and we've got Kevin, who is the resident book expert. which is I really appreciate Kevin you joining us today. And then we've got Stef, of course, and Stef is our kind of our link with the book stuff. So she's good for answering questions, but also for kind of being here as part of that and on screen with us. So thank you all for being here.
So we have had a few questions come in. If I can dig them out of the chat history here.
Okay.
Let's see, we'll go all the way back to the very beginning. Sorry, bear with me any second now.
One of the questions I see is why we postpone chapter 13.
That is literally the one I was trying to find. There we go. There's Ali. So we haven't postponed. It just got switched around because the order made more sense this way. So we've been dealing with networking, serialization, then the accessing of the network with Chopper and then streams, which kind of, we'll see that in a minute. I'll go in with Chopper, and then state management to manage that data we now got from the network. So just putting it in this order makes more sense, and that's it. Just for you to really get a hold of the material. Any other points from anyone?
Well, I'm a little curious on that. Maybe Kevin could jump in, but how did you guys decide what order to put stuff in?
Well, I will say that state management is a pretty big topic. There's a lot of things, and so it kind of stands alone as its own chapter versus we can cover more things with the other chapters. That might be partly why Craig
we want to group two chapters together. That was another point, right, just to get the ordering right.
Right.
But I mean, from the book perspective, I guess it didn't really make that much difference because we weren't grouping things together that way.
Right.
Steph, do you want to speak to that? I mean, do you know why the chapter in those in that order specifically?
The authors decided the chapter order, so yeah. I edited once they gave it to me. So
that was me.
Back to Kevin.
Right. All right. Let's see if we can get the next.
Just a little on that point, when you're building up an app, for me, that's kind of how it flowed. It's like, okay, I can do networking. Now that I've got networking, now I need state management. So it kind of just worked out that way.
So right, we have our next question. Sorry for interrupting you. You can also go. It's fine.
Yeah, we normally decide on this beforehand, so this is happening a little bit different for us. But yeah, DMA asks, does Chopper package support form data?
So I had to go look this one up when I saw the question come in. So I went and looked on the API reference from the Chopper package on pub.dev. It doesn't directly support it as in like an annotation that you can directly use. However, it does support multi-part mime, which is what form data is. So if you go look up how form data is sent, you'll find it. You'll find it's multi-part mime, and then that will give you the link between the two. And sorry, was anyone else's input on that?
We have some Adamu in the chat actually says that Chopper supports form data by writing a function that would modify the request object and add multipart, and then the content type should be set to multipart/form data with that. It's supposed to work.
There is actually a multi-part request. What's it called? There's just a multi-part class annotation you can add in your requests, and then on each of your parameters you can add an @part file or @part, and you can pass it in that way. I think you can provide the content mime type. There should be no reason why you can't. But yeah, it's definitely possible.
Great.
What else do we have come in?
We are a little short-handed today, so Simon's having to pull double duty here. So thank you, Simon.
Yeah, we're missing a few people today, so please.
Yeah. And I was thinking earlier when I had said I wished all the Americans happy Thanksgiving. I'll wish everybody happy Thanksgiving. You don't have to be an American to enjoy a day. So. All right, Kratos M says, any sources or recommendations where I can learn more about code abstraction and such?
That's an interesting one. I can't think of one particular resource on that topic alone. And honestly, I think you'd be looking for just Googling around for object-oriented programming. And that would give you sort of a head start on some of the concepts. And there's also design patterns, and that's code design patterns, not paint sort of designer patterns. I guess if you look up those two topics, I can't think of any particular materials, but that's because I just learned it myself, so I can't really speak to any.
You can also go to raywunderlich.com and do a search, because there are design patterns, and if you have a subscription, you can have access to the books, but there are free articles there too, so I highly recommend going and taking a look there too.
Yeah. That's a great point, Stef. And here, like I mentioned, it's Thanksgiving weekend here. And often right after Thanksgiving, we have Black Friday here, which is a traditional time for lots of sales and things like that. Does Ray Wunderlich have anything going on like that?
Yes, there is a Black Friday special for the Ultimate subscription. It's discounted pretty I think it's a good price. If I wasn't part of the team member, it would be something I'd definitely consider. It's limited. There's a scroll going across the bottom with the link to it. And
the link is also in the chat.
It's also been put in the chat. Also, you can, and I forgot Simon was on screen there, sorry, so I just repeated. Anyway, so with this particular subscription that is on there, it's access to everything, not just our book, but all of the books, all the video courses. Of course, they still have access to all of the articles. There are learning paths that are there too, so definitely go and take a look at it. Now's a really good time to do that too.
Cool. See if there's any more last minute questions, and then we'll get on to part 2. Is that, I think,
absolutely, yes. Because Craig was nice enough to record 2 videos for us. So, Richard Hune says, "Is Chopper the de facto library for enriching the networking experience on Flutter? Is the way Chopper handles HTTP requests the same way other libraries handle them?"
I could speak a little bit to this point. So when I say, I mean de facto, the one that people go to, I guess. I don't know. So so that this enrichment networking stuff for myself, I first heard about this back in sort of like 7 years ago in the Android days. It's called Retrofit, made by Square, and they made quite a few packages for Android. Someone has made a Retrofit clone as a package on pub.dev. You just search Retrofit, one word. That's one people do use. However, I think Chopper is a bit more mature as a library goes, but under the hood, they all use the same HTTP library that's built into Dart. They all use the same mechanisms. I mean, a lot of the time, it can help to roll your own. I mean, like it's if you looked at if you just watch the video there, it fixes a little bit of code for you, right? And it allows you to easily change something. Like, I want to change this request parameter, and you just change that annotation and you regenerate the code and you're done, right? You don't have to figure out where you're passing it to, what types are, I don't know, all the other sort of things. So it just gets rid of some of the boilerplate. But apart from that, it still uses the same library underneath.
Well, Kevin, since we got you here, why did you pick Chopper?
I'm very familiar with Retrofit, and so I was looking for something similar to it, and so that's kind of why I chose it. And it's got a very high, like 97% popularity on pub.dev, and so I tend to pick the ones that have the most active use and what people are using. So.
I mean, some of the point of what we've been doing with the Flutter favorites is just to look at what's active, what's being actively maintained, is it being used the community, get involved. Chopper is one of those packages for sure. All right, I think we have a couple more questions coming in.
All right. Satyajit, I hope I get your name close to it right. Our app is following add to app strategy and we have some weird restrictions. What is the recommended structuring of the project if we are not ready to move away from native yet? Okay, so I guess to know that, first off, add to app strategy is a way that you can convert part of your app, right?
Yeah. So that's where you can say, like, add a module of Flutter to your existing Android app, and then you can use the Flutter views across your app, like for an entire screen, just use an entire activity or a fragment or just a view. And yeah, start your Flutter code up from any one of those things.
Does anybody have any advice for Satyajit?
Is there any recommended structure?
Yeah, I know our company, we've been playing around with just testing different scenarios. So we tried, doing one module, this Flutter, that's just like one screen, and different combinations just to see what would work better. I did also try to create a plugin for our regular app, and it was kind of a pain. So there's different things you can play with.
I would say that there's some nice stuff out there. So like Pigeon is now being made, so that really helps when doing the method channels. So you can do this thing where you put your UI, you can keep your business logic in your current existing native implementation, and then just rechange your UI and slowly take over your UI with Flutter before you replace entire sections or screens or the entire app if you wanted to. To be honest, it's just unique to your application, like what your application does. I don't think there's any particular recommended structure. What I would suggest is just doing it section by section, right? Like work on one section. Like the problem is if your section of your app is linked into the rest of your app, then you need to isolate it, right? So that you can transition it away. So yeah, you need that separation of concerns, basically. And then once you've done that, you'll be able to replace it with a Flutter implementation, Flutter Die implementation if you want to, and then do that section by section.
All right, guys.
I'm gonna just bring up a quick question off track. I just saw this. Does Flutter do isolate off-thread parsing? I have no idea. However, I'll be honest with you, I've never once had to do this. Maybe twice in some early days I tried it, but it's not on a day-to-day. Unless you're parsing megabytes and megabytes of JSON, you're not going to see any performance impact on your UI because it passes the JSON in clumps and they're done between frames. So you'll never get into a situation, you shouldn't get into a situation where you're really passing all too much JSON to warrant putting it off into an isolate. Spinning up an isolate is a heavy task. So if you do this, then you want to spin up one isolate and then do messaging. As we handle it a message and you get a return response from that message, so that your isolate always stays running for parsing. But honestly, I think it's a lot of headache for not a lot of win. I'm not sure if there's a library that does this actually for you. That would be quite a handy thing to look for.
Well, maybe you can look while Craig's doing his next video.
Right, we've got a couple more last-minute questions coming in, and then we'll jump on to the second section, I think.
All right, perfect.
Because I don't want us to get behind schedule. I think we're okay at the moment.
All right,
okay,
so MD Yasin Sheikh asks, what happens if we use multiple use widgets that can be just handled by single widgets, like sizebox padding instead of container? So I think he's asking, what's the use case for if you have one widget that can do it all versus wrapping it multiple widgets? Is there a difference?
Slight difference. I can tell you why I do it personally. I don't use container. I got off using it because it can't be made constant, and I like the idea of my entire widget tree being made in one constant constructor and then being reused across the application. So I can put a whole bunch of constructors in one, the widget tree itself into one constant implementation, which I think would get more performance out of your build phase of your cycle. So that's the reason I prefer to use sizebox padding and other things. Also, if you look at container, that's all it does. It says if you specify padding, add a padding widget, but it does it with a clump of logic. So it's always going to call some functionality to rather than specifically that one widget. But yeah, there's at some point, if you're going to use every feature of a container, well, then use a container, right? So yeah, that's what I'd say.
I think how it reads, it can make, sometimes it's more obvious seeing it, and sometimes, like you said, if you're using every feature, then sure, use a container. You're talking about making constant constructors and things like that. Isn't that kind of why Craig in his video was using copy with, on the request, was so that everything can be final in the widget?
I might have missed that bit.
Okay. Then yeah, I think that's why,
that directly.
Yeah, he was doing a copy with to make changes when things were coming in. I'm presuming it's so that he could have everything final in there.
I mean, most of the time that's because you have your data is mutable, right? And if you have it, the idea of having immutable data stops the sort of data mutation. So this happened, I'm just going to explain this briefly right now, and that is a lot of apps have stepped away from having mutable data models because you change the data and you forget to update the UI, right? Then you have inconsistent experience from the user to the model. So the app, it thinks it's one way and the user thinks it's a different way. Does that kind of make sense under the hood? And when those two things happen, it's really hard to find those bugs. And when you get those bugs, the user says, you see the screenshot, it's this. Yet in the back end, it's completely different structure that represents it, or who knows what. So the idea of having immutable data means that you can modify the data, update it, and when providing that new data model that represents your UI to your build method, essentially then everything is getting built that represents that model. So you can be guaranteed the two parts of your app are talking the same language as well, and everything's in sync. So it gets rid of a whole slew of bugs that is potential bugs, and that's just an advantage of doing the declarative layout and immutable models together. Really work really nice, really work well together. Anyway, I'll shut up.
All right, do we have maybe one more question?
I think we have a couple more questions and then we'll call it. So
okay. All right. So DMA asks how to handle OAuth 2, i.e. the refresh tokens part of that with Chopper.
That's
Kevin.
That's what interceptors are for. So basically, you just every request, whatever, you can add your authentication token in there. You could check see if it's expired, do a refresh. That's even if you're doing it in like Android or so forth, it's kind of tricky because if you need to refresh your token, then you have to do another network one in between. So that's kind of tricky and stuff. So, but yeah, that's what you do in interceptors. So
I just posted the documentation link for interceptors into the chat. So I hope that puts you in the sort of right location on adding your own. What else? One more question, I think. Right, the last question before we get to the next one.
All right, Secret Agent Man 00 asks, do you recommend learning native iOS or Android first before learning Flutter? And Steph, I think you definitely have an opinion on that, don't you?
Yeah, I do. So my history is a SQL developer, over 20 years working in that. I dabbled some in iOS, never did anything in Android. So when Flutter came along, I was in heaven, the fact that I could write something that would be on both platforms. It's really pure personal preference, but my recommendation is go with Flutter. And then if you need to have something that is a native iOS or Android, then do that, but start with Flutter.
There's a lot you can do with just Flutter alone, right?
Yeah.
Like for most applications, there's no need to do anything that's particular to the platforms. And if there is, there's probably a generic package that does it for you. There is obviously an advantage, but it all depends on what you're doing, right? So yeah, if you're trying to take advantage of this feature that's specific on Android that there's no package for, you're going to need to know Android to make that plugin yourself, right? So, but yeah, I don't think there's any advantage to learning it first.
Yeah, so one of the things I find interesting is I've been doing some Kotlin multi-platform programming, and oh my gosh, compared to Flutter, it's so much harder, So
really?
Oh my God. Yeah. So like the YAML file for the packages, you just put the package in and boom, it works. Whereas with Gradle plugins and all this stuff, it's such a pain. So I definitely recommend just doing Flutter. And then if you have to go into the different paths to learn certain things, do that.
So sorry.
I also just want to add a small thing.
Go for it.
So I was actually a Python developer before, and I just directly dive into Flutter. It's also quite new, but what I can say about it is definitely not a must to know native iOS or Android, but lots of if you're not familiar with the mobile app development, then everything is just getting super weird about it. But you will notice that some people have an Android background or iOS background is using some packages because they are just familiar with that method. It can be state management, it can be some stuff that they handle, but you can be sure that you will just have lots of trouble when you have trouble with the build.gradle file, the pod files in iOS, and so on. So these are kind of crazy.
It's interesting. I will mention this now because I saw some comments recently about this. Like someone saying they had problems with dependencies when doing Flutter, and it's like, well, yeah, you're gonna if there's native dependency problems, then you're gonna have those with the packages that you've chosen. There's nothing you can do about that because you would have them anyway if you made it in Android. The same goes for iOS, right? If you've got pod file conflicts, that's something you have to fix because that's the way iOS works, right? You're building for those platforms. But if you build it natively, you still have those same problems. You haven't
exactly.
I think the problem is when you're doing Flutter, it's so quick and easy that when you get these tough problems, you're like, oh, I have to deal with this now, and that's what makes it feel really annoying. But it's not actually anything that you would do if you're a native developer, right? It's just that it hits us harder because we work so much quicker in Flutter.
Yes.
And one thing to also remember is with Flutter, you've got a cross-platform development. You can create an app and it goes to multiple platforms. You don't have to worry about learning iOS and Android. That's for me, that was the biggest selling feature. I mean, I was sold just on that sentence. It's like, okay, I will do this, and I haven't looked back.
It's interesting. Like we hear a lot. There's less now, but that I hear at least, but more earlier on. There's the question of, oh, I have to learn a new language, like I have to learn Dart, right? And it's like, well, not really. So yes, it is a different language. It has some different syntactic differences, but it's not. It still C syntax, style, curly braces, all that kind of stuff. It sits in the world of languages. It sits between like JavaScript, Swift, and Kotlin. So if you're used to any one of these languages, you can jump straight over to Dart, and within a small period of time you're using it. I think it's more about learning that common library and what methods to call for doing certain actions and how they're different from other ones. But it's like anything. When you do something new, there's that hump to get over, sort of the learning. But once you're over that, you're kind of smooth sailing, I think. Right. I'm gonna cut in Esra, but so we have a second part. Make sure your questions keep coming because we will get to them after this next part. Okay. Yeah. Anything wants to be said by anyone?
Nope. Let's take it off and let's have Craig tell us all about his next
streams
presentation. Streams. Yeah, streams.
All right. See you guys in a bit.
Okay, folks, it's time for chapter 14. This is in week 7 of the Flutter Apprentice Book Club. And right now we're covering streams. And I think streams in Dart are pretty neat. So I'm excited to talk about them. Oh yeah, this is what we're going to do. We're going to talk about what streams are. Then we're going to look at the stream controller. Then we'll look at some stream widgets. And finally, the block pattern, because it is basically just a wrapper on 2 streams. And then we'll code some stuff up. So what are streams? Well, you can kind of think of them like a little conveyor belt. They're a pipeline. The book literally describes them as a stream with like boxes floating down the water on in a small river kind of stream. And probably wouldn't be boxes floating down the water. No, would it? They would. The cardboard would get soggy. But anyway, it's just some pipeline where our data is moving from the beginning to the end, and along the way, stuff can look at the data and react to it, update it, change it in different ways. And the stream is asynchronous, right? So new events, new items, whether they're a log floating down the river or a box on this conveyor belt, they can just kind of appear in rapid succession. There can be stretches where nothing happens. And the whole point of the stream is that you agree, if you're doing stream stuff, then you agree that you're okay with them coming really in, coming in hot for a bit or just being silent for a while. So in Dart, it's just this whole construct. It's a bunch of machinery for you to be able to listen to events from some other place whenever they appear. And if they stop appearing, you're willing to wait. So in Dart, this whole conveyor belt that we've set up here, the equivalent code for this is stream controller, right? You'll see this a lot as you keep going, and you store it in some variable, normally a Gallic controller. So to put something on the beginning of our conveyor belt, you call controller.sync.add, and you can actually skip the sync part, which is interesting. You can also just call controller.add, same thing. But we talk about the sync. And why is it called a sync? Well, because as far as I can tell, it was named poorly. But it's almost like a funnel that's just like sucking stuff in, or like the bottom of a kitchen sink where things are now entering the drain, which is kind of like a pipeline. So this is how you put stuff on the beginning of the process, and then it zips through the process. So that's the line of code that you write on that stream controller that we can see we created before. And then eventually the box is going to get to the end of the conveyor belt. And to have it, do something other than just like fall off on the ground, we would want to add a listener. And this is like a person at the end of the conveyor belt waiting to grab the box and do something with it. And the actual line of code that you write for this is controller.stream.listen, and you pass it a method or a function that itself, that thing that you pass, that function should be willing to accept an instance of whatever is going through the stream. So each, maybe you've got a stream of strings or a stream of Booleans or a stream of numbers or chat messages. If you've made a chat app, then that method that you pass to the listen method, your thing should be able to accept either a string or an integer or a Boolean or a chat message every time one appears on the stream. So this is probably the simplest bit of code that we can see, and it's very similar to what we just saw in the last screen. In the first part here, we set up a stream controller, and then it's always nice to have a listener in place first. So we'll actually do that part first. On our controller, we'll say, hey, Mr. Stream or Mrs. Stream, it's a new thing. There's a new person standing at the end of the conveyor belt, and when one of the boxes is about to fall off the ground, instead, they're going to pick it up. And so what do we pass in? Well, it's this method that says, it receives a value right here, and then it just does something. In our case, it's just going to print the thing. And then we actually add an item on the beginning of the conveyor belt via controller.sync.add. And so we just pass it a string here. And why is a string acceptable? Because we told it up here that only strings are going through our controller or our stream. And so what will all of this code do? It will just print new stream value, hello world. And admittedly, this is a bit like going around the block to get next door, because we could have printed that way more easily. But streams are interesting because all the different players can come from radically different parts of your application, and the data itself can come from a network connection or user interactions, which can be are hard to predict. When will the user touch stuff? When will they drag their finger? So streams give us a lot of power to respond to stuff in real time. Now I want to talk about some widgets that actually use streams. In chapter 14, they talk a lot about a stream builder. And a stream builder is an awesome widget. So I just wanted to think about what is going on inside a stream builder, because I think that'll make it a little easier to use. So first, we're going to code a very simple widget that operates on a stream, but it's not even accepting it in yet. This one's just called stream text. So on the left, we have our stateful widget, very standard. It just immediately turns, passes the baton to the stream text state class, which is defined on the left. And so here, this has a stream controller of strings. And what is it doing? Well, in init state, it sets up a listener. Okay, so we see down here that in init state, we add a listener, and the listen function that we pass is update value. Okay, got it. So update value is a method that accepts a string. Okay, that all sounds like what we were talking about earlier. This is good. So what does update value do? Well, it updates the value and it calls set state. This is very fluttery, obviously. We want to update our UI. All right. Notice now also in init state, we saved our subscription and we can dispose of that down here. Well, actually, I should have closed the controller as well. This was incomplete, but points for trying. Points for thinking about it. And then in our build method, which is where things actually are interesting, we're going to print the text here. So anytime our controller updates, the build method will print that new value by way of all of this machinery here, from this line down to the end of update value, where it calls set state. Now this widget that we're looking at is pretty contrived because the stream exists entirely within the widget. So we have not written any way for new text to actually appear here. But this is just a very generic thing to kind of get us thinking about how do these widgets actually stitch themselves together. So now let's look at a more realistic version of Stream Builder. And this is not the code within Stream Builder. I didn't even look at the code in Stream Builder when I wrote this, but it's going to be very similar. So on the left, we have Stream Builder, and it has a type now. Okay, that's the first difference. We did not bother having a type over here because we just knew that our type was strings. But Stream Builder wants to be generic and helpful, so it's going to let you pick the type. So as we're coding Stream Builder for future us or other people to use, we're going to let them pick the type. So we say it's just generic T here. Oh, it wasn't supposed to go forward. Good, we're back. Okay, so you've also seen, if you've used Stream Builder or if you read chapter 14, that it accepts a stream and a builder. All right, and these are the variables that it accepts. Great, and then it still pretty quickly just passes the baton to the state object. Every stateful widget does that. All right, what is happening in the Stream Builder state class? Well, init state looks very similar, doesn't it? Except the stream now comes from widget.stream. That's what's up here. Okay, well that makes more sense because we already knew that in our last version, we had no way to actually get this stream to do anything. So it's great that it's going to be passed in, because then something else can actually call that sync.add method. Update value, no change, except that it's now an object. This can actually say T. I don't know why I didn't write T here. It should say T. I told you I didn't look at the Stream Builder code, and all the mistakes are proving that out. Okay, but now let's look at the build method. This is where it's interesting, because the build method takes the context and an async snapshot, and this is not how you actually instantiate an async snapshot. This is pseudocode. With our value, though. And the value was set anytime the stream updates. So we said, okay, stream, whenever you update, call update value. Update value is ready to do the thing. It update, value comes in. This is hot off the presses of the stream. I keep doing this. I'm trying to draw boxes. That's not how it works when you're presenting. This val, hot off the presses from the stream. Okay, we're going to save it and call set state. We all know that set state means the build method runs again. What does the build method do? Well, it has no idea, because the whole point of this widget is to be generic and let you specify stuff. All that this widget does is handle the stream annoying boilerplate for you. So you pass in the builder. And this is the code that we write in a lot of a lot of widgets actually. And this is the kind of stuff that's happening under the hood when we use one of those widgets. So its build method is just like, I don't know, but you gave me a build method, right? I'll call that one. And then another incomplete dispose method. I needed to do more with the stream. Anyway, this is pseudocode for how Stream Builder works, and it paints a decently accurate picture here. So you've probably heard of block when you are fluttering about on the internet. And block, you may know, stands for Business Logic Component. And this is a just pattern idea for how to build UIs, how to manage your state and have your state respond to UI, or saying it's totally backwards, have your UI respond to state changes. So business logic component, block, it's one of the big patterns of state management. What we're gonna do in our stream implementation here is actually code some raw block style state management. And this is gonna set us up for next week when we rip out all of our raw block stuff, just like we did last week. We wrote some raw API things, and then this week we said, forget that, we'll use Chopper. This week we're gonna write some raw business logic component state management, and then next week we're gonna replace it with Flutter block, and then we're also gonna compare that to RiverPod. So stay tuned for that. But this is gonna be kind of those underlying concepts that are what block is, and it's what Flutter block does. Okay, so let's think about what's going on in block, in that pattern, in a state management like that. So this is kind of a similar screen to what we had earlier. Everything on the top, this is your block implementation that we're about to code, and then you've got your Flutter app. So something happens in your Flutter app. You make an event, okay? This could be a user click, this could be some data came back from the server, who knows, right? Some event happens in your app. And then you're gonna call block.add my event. And that add method is named that for a reason, because the block is just a container on a couple of streams. So there's a stream for inbound events. The block is listening for events. And so that event goes into the block, gets evaluated, operated on, whatever needs to happen. That's code that you write, that we'll write together. And then coming out the other side is a new state object. I have no idea why I capitalized it like that. Maybe it would be the variable name. Yeah, that's what I was thinking. So our new state object comes back, and this is an instance of whatever our state class is. And our state class then goes back into the UI into a stream builder widget and rebuilds our app, or whatever the part of the UI is. So let's continue to look at how this might look. This is a very, very simple version of a block. So let's look at what it does. We've got a couple of different stream controllers right up front, and there's this my state class. You define that. And then my event class, this is where you capture what it means for something to be an event in your app. And so we say that we have our state controller and our events controller, okay? And then in the body of the constructor, we immediately set up a connection between the two. So we say whenever there is a new event coming on that controller, let's wire up our process event method, okay? And then here we just have some variables, so that's not too wild. Actually, all the way down here, we expose the stream, but process event. What's going on here? So process event says, this commented line of code is supposed to be like, you actually look at the event, you figure out what it is, and you make whatever updates to your state value that you're holding on to, which remember we've got right here, my state class. We're holding on to one of those. So we've looked at the event, we've figured out whatever its details are, we've taken all the appropriate actions, we've modified our state, variable, and then we put that state variable back in the state controller's sink. We add it, and that's going to allow the UI who's listening to rebuild. So, and then, you know, we had our stream thing here. This is just exposed. The stream is what the UI listens to. So it wants to know when there's a new state, right? When has the state of the app changed? Not all events will actually require a redraw. And it'll be the block's job to not yield a new state value if that event didn't matter. And then there's this add method. This is also what the UI puts events into. So we can see here that block, the pattern and an instance of it is just a wrapper around two streams. And there's one method that connects inbound items from the inbound stream, figures out whatever needs to happen, and then puts an item on the outbound stream. And on both, and you know, the other end of both of those streams is our UI. So it's time to write it. It's time to do it for real. I'm gonna zoom out. There we go. All right. So we've got a bit to get through here. Let's do it. We're already checked out on, what are you barking at me about? Don't care. All right, we're already on chapter 14, step 1, add apod block. So the first thing to do here is open up that file, apod block. I love that it opens all the files at the bottom. Okay, we're gonna build this up incrementally. So I've just started with all the boring boilerplate. We've got our state controller, our events controller, and we actually have two classes here. So we're gonna look at that too. Note that our apod block, this is destined to replace favorites manager, which remember has long been a bad name and it should have been apod manager. So our apod block is going to replace the apod manager. And we know that it'll need access to the data layer. So of course is going to accept a repository. And you know, then the rest of this code just kind of looks like what we saw a minute ago. We've got our process event method, nothing in it yet. And we have our stream. This is what the stream builder widgets will listen to. Then we have our add method, which accepts new events. And this is what all kinds of different widgets will call whenever they have a new event to report. So there was apod state and apod event. We saw those. Let's look at them. Apod event. This is what our UI is going to create an instance of whenever something happens. Right now, it's really advanced. It's exciting. It will get more advanced, but not yet, because this is just the boilerplate, the skeleton. All right, apod state. How exciting do you think this one's going to be? All right, so all of these are in our future. Now that we've got our apod block kind of sitting here, let's take a step forward. Check out chapter 14. Is that where we're on? Step 2, convert current apod. Yes, all right. So in this part, we are going to spoil a bit of the punchline. We're going to actually convert our current apod page to use this new functionality. So the first thing that we need to do is look at our main.dart, and we'll notice that we actually add a new provider. And that is going to return what it provides is an instance of this apod block. And another really interesting detail here, notice our apod repository, you know, the favorites manager is going to go away. But like you could imagine a scenario where that's not true. And it's the same apod repository, which is our data layer that goes to both of them. And this is where even having a data layer so distinct like we've got is going to pay a lot of dividends, because the favorites manager, if it was going to stick around, and the apod block can share that local memory source object. They don't need to both load objects and keep them in memory, right? If an object is needed anywhere, it's stored in memory once, and then it's available again anywhere someone needs it, as long as they use the same apod repository. But that's a divergence. We're thinking about block stuff. So that's the end of main.dart, I think. Yeah. I'm gonna go back to current apod tab. All right. So things are different here. We're no longer using the favorites manager or the APOD manager or however this was written before. It doesn't matter. We're only looking forward. We've got an APOD block. That's what we're pulling out of that provider. And now we're using a stream builder. We used to have future builders all over the place, and now we have stream builders instead. So this is a stream builder for APOD state values. And what is the stream that it listens to? Well, our blocks stream. Okay, let's remind ourselves. APOD block. What is the stream attribute on the block? Well, it's the stream attribute on its state controller, which holds APOD states. So that all connects the dots for us. We've got APOD states that are in the APOD or in the state controller, and the state controller stream is what we return on this stream. And it even says here it's a stream of APOD states. Okay, that all makes sense. And so then back in our UI, the stream builder that wants a stream of APOD states is able to use that. Okay, that seems pretty good. And then there was that builder method, which we saw on the slides, where we're allowing someone else to actually decide what happens when a new value comes off the stream. And I say we're allowing someone else to decide. That we're is the authors of the stream builder widget. So it's actually not we, it's someone else. But they're allowing us to decide what happens when the stream builder yields, or sorry, when the stream yields a new value for our APOD state. So what is this doing? This kind of looks a bit like our old future builder, because it gets an async snapshot, which is the same thing a future builder got. Oh, you know, so we just make a couple checks. If you don't have any data, all right, loading indicator. If you do have data, but it's like null for some reason, then loading indicator. This isn't the best error checking. That's a theme in our app, by the way. But finally, we actually have our APOD state, and today's APOD was not null. Okay, by the way, what the heck is today's APOD? Well, let's find out. If we go back to APOD state, I just added today's APOD, and it's a nullable picture of the day variable. So that's all that is. APOD state learned about a little bit of stuff. All right. And I need to be running the app here. macOS, yeah, run. There we go. Okay, that's good. And then when we finally load our data and it's not null and everything's in order, then we get to return the UI. Now, there's a problem with how we've written this now, which I could have showed you immediately if the app was running, but the app is not running. But what we'll see here is that the UI that this builds is a little underwhelming. And it's because there's a first kind of domino that needs to get pushed over, and we are not yet pushing it over. So hopefully the app will build fast. That's an old song there, sung by the ancients. Hopefully the app will build fast. Okay, I promised you that the UI wouldn't be exciting, and here we are looking at a not exciting UI. So we're getting kind of stuck in one of these spots. Something ain't right. And let's take a step forward in time to see what we need to do. So git checkout. Oh, by the way, let's just remember for ourselves, this is a stateless widget for now. A lot of our things have been stateless widgets, but we're going to do git checkout chapter 14, step 3, I think. Load current APOD with block. Haha, that sounds promising. Okay, so we are now going to be a stateful widget. And what are we doing inside here? We've got a late APOD block variable, and instead of grabbing the block in the build method like we used to do, we'll load it in init state. So this line of code is straight out of our old build method, but now it's in init state. And hey, this is interesting. When we load this page, we're going to add to the block's event stream the load today's APOD event. Huh. All right, well, what the heck is that? Well, our APOD event class became abstract And now we just have load today's apod as an extending class. And you might be tempted to look at this and go, hey, and say, hey, couldn't this just be an enum? And as long as you never have any variables attached to one of these events, then technically it could be an enum, but it will pretty much always end up having variables attached to some of your events. So stick with classes and not enums. Okay, so our event has some stuff. Our state has some stuff as well. More stuff, interesting. Let's look at the block. Process event. This used to do nothing. It received the apod event and did nothing. And we knew that that was okay because we hadn't written any code around any of it. So that was fine. But now we're actually adding an apod event to that stream. And so process event is going to have to do something with it. So we say, all right, well, if the event is an instance of today, load today's apod, then we'll go to the repository and we'll call get item on today's date. And then we'll use this new method, state.copywith today's apod. All right, we kind of saw that a second ago, but our apod state, it used to end here. This was the definition, but now we need to start being able to update our app state as we go. And remember, immutable data saves us headaches. So we can, we'll need a copy with method. So we saw this when we were using freeze, that copy with methods are a thing. We're not using freezed yet, specifically because I'm going to next week, and I want us to write this code kind of painfully by hand so that we can appreciate how much freezed simplifies this stuff next week. So for now, I'm just writing this all by hand. We're gonna suffer through the copy with method and everything else that we need. But all right, that's our apod state. And if I rebuild now, it should actually work. Close all the files here because pushed the first domino. And hey, all right, Saturday morning for me. Hi, Wednesday. But yeah, the first thing showed up. Awesome. The other pages still work because they're still using the favorites manager. They're not even using block yet. But we're going to convert all three of these favorites tabs, or apod tabs. Okay. Next step is the detail page. So let's go git checkout chapter 14 step 3. Yeah, that's what we're on right now. I see it right there now. 4. There we go. Add or apod detail via block. All right, so let's look at our apod detail page. It's a stateful widget, just like we ended up having to make the current apod widget. It was stateless before, so is this. They all have to end up being stateful. Okay, we scroll down. I'm not even on the right thing. Oh, I am on the right thing. Exciting. Okay. Anyway, in our apod detail state, we have, I was confused, there's a lot more going on in this one. But we, in our apod detail state, we have the same thing, late apod block variable, and we grab it in an init state. And we're already, not going to waste time failing to push the first domino. We just add the initial event. So, okay, load specific apod. This is interesting. Let's take a peek at that. And we see that apod event is continuing to grow. We used to only have load today's apod, and now we already have load specific apod. And this takes a variable. Could you retrofit load today's apod into load specific apod? Boy, you sure could. You absolutely could. But we're not. Guys, I want a demo having different types of events. Okay, how does this work? Well, it's a stream builder. It listens to the stream exactly like the other one did. It takes async snapshots of apod state, check whether or not we have any data. And then there's a new getApod method on our apod state. And this means that our apod state class is growing. And I was thinking ahead, we're going to get to the recent tab with the list soon. So we'll just start setting up something for that now. And then we've got some internal shenanigans going on here so that we can grab a specific one from the list. So we store a list, but then we'll also kind of shove it into a map anytime someone wants a specific one, and then we'll just be able to look them up nice and easily. Copy with method had to grow because we have more variables now. So I can't wait until we get to write all of this with freezed instead next week. But not yet. So let's look at our apod block because we had a new event. This is another thing that freezed will simplify next week. You could imagine just kind of forgetting to write this code, and the linter is not going to tell you. You're not going to realize that you missed one of your events until you write unit tests for it or manually, clicking through your app, recreate that scenario. And if it's a really esoteric event, maybe it's easy to overlook, you could forget this, and freeze will help us with that as well, which you'll see how next week. But okay, what if it's load specific apod? Well, then we go back to the repository just like before, but we get to use the event ID, which is awesome because that's the apod ID that we need to load. And this is really cool here because if we get here by clicking on an apod, then we already know it'll be in memory. And what's our repository going to do? It's only going to hit that first local memory source, immediately return. We're not going to make any network requests. But what if we get here via a deep link and nothing is stored? And it's a new API, or it's a new picture for us. It's not even in Hive. Well, this will just work. So we're writing this in a way where we can land here via a click, and we know it's already in memory, or it's the first place we've gone and we've landed on this detail page, and we're going to need to use the full scope of our repository class. And the fact that nothing else around us knows how much work the repository has to do is so helpful. So this is our load specific apod handler, the section for that. We get the thing, and we copy the state object, and we add the thing, and I'm like, oh boy, this is starting to get a little annoying. But it's not the end of the world yet, and we know that we have help coming next week. But okay, so this was a specific page. So if I rebuild now, and then click on this, we're on the detail page, and this is happening via block. All right. I like that. I'll take another step forward. Check out chapter 14, step 5. Recent apods. Let's look at that. Recent apods tab. Same thing. We've got our late apod block. It's a stateful widget now. We can grab it in init state. We add our first domino. The pattern repeats itself. We have a stream builder. We read from the stream. We say, hey, do you not have any data? If you don't, loading indicator. And then we already added the apods variable to our apod state class. So that's already ready for us. Didn't have to add it in this step. But we'll just check, hey, are you an empty list? If so, loading indicator. And then finally, we load the UI. So this code, it's all we had before. And this has been true on every one of these pages. Once we get down to this, finally return the actual UI comment, the code that ensues, nothing's changed. So, all right, but we do have a new variable or a new event again, load recent apods. Okay, pop over here. Very simple. Not a lot going on with this one. But this apod event file is just kind of starting to, is this just going to kind of go on forever here, like adding class after class after class? The answer is yes, unless we do something, unless we start to think about these more cleverly, and that's where Flutter block and freezed come into play. Because remember, this is just the raw block implementation. Okay, so this is apod event, and we should expect to have a new apod a new handler section in Apod block, and we do. Process event has grown again, and we now have load recent apods. And look at this. It calls get items, and our manager, favorites manager, should have been called apods manager. Used to do this check where we'd say, hey, is the length enough? And if it wasn't enough, then we'd make this remote request again. So that logic lives here now. And then we return the states and we sort them again. Just kind of realized I'd forgotten something. Sorting now appears in all of them. So good. Okay, I think the recent apods page is probably going to work now. Back, we load here, we go to favorites. That's not what I wanted. Yeah, here we are. Great, we've converted the recent apods page. And folks, this is state management via block. If this kind of made sense to you, then you'll like Flutter block. But one thing, and this is the final point that I want to make in this section, when people get into Flutter, they find that there's so many different state management solutions, and every Flutter beginner is right. You are correct to ask the question, what state management solution should I use? What's the best one? And the answer that you'll almost always get is so unsatisfying. Someone who's written a lot of Flutter and has checked kind of all of them out will look, they'll look at you in their answer and say, I don't know, they're all fine. Use whatever one works for you. And then as a beginner, you're like, that is the worst answer I've ever heard. What are you talking about? How could that be your answer? Well, we've been kind of state managementing, which is a word, with provider this whole course. Right? We had change notifiers. We called notify listeners, the UI rebuilt, and we had favorites manager or future builders all over the place. And it was kind of like light state management, right? But it totally worked. It totally worked. And then, haha, we're using block now. Block's the best. Woo! And I actually do. I use block. I like it. But block's the best. Yeah. Well, is it? I mean, we just swapped out our future builders for stream builders. We still have this builder thing. We're still using async snapshots. Sure, like on our block, we don't call notify listeners anymore, but we got these streams instead, and they're doing the same thing. Those other notify listener, all those widgets that we've been using, they use streams under the hood. They use stream builders under the hood. So we've converted to block here, and just all of our logic has moved somewhere else, but it's pretty similar. We used to do all of this stuff in our old state management solution. We used to do all these things, right? This line of code, I just copied this over from the favorites manager before I deleted it. And nothing changed. So what's kind of more important actually is to have that discrete data layer. And then your state management solution, and we're going to look at Flutter Block and RiverPod next week, but we just kind of coded a vanilla one up from scratch, and they're just kind of all starting to look the same, aren't they? They all work. This is a good thing. They all work. But that's what's behind the answer that you get from developers that have kind of kicked the tires on them all. When you say, what's the best one? And they're just like, I can't just tell you to use one. There's no silver bullet. Got to use the one that works for you. This is what they're thinking back on when you get that answer. So anyway, that's enough of me rambling. Let's do questions.
Hello, everybody. All right. So thank you, Craig, for recording this session for us. That was amazing, as always. So we are ready for our second Q&A session. And if you have questions to help us find, please just put Q in front of it, and we will read and answer them as possible. So let's bring Simon, Stef, and Kevin for our Q&A right now, and Danielle.
To say, don't forget me.
Just before diving into Q&A, I would like to throw the ball to Stef. And if you spot any errors in the book, what you should do? Do you want to answer, Stef?
Sure. So if you find errors, we're all human. We make mistakes, and we have an errata link that's going across the bottom now. So go there. First read to see if it's been reported. If it hasn't yet been reported, then go ahead and enter an errata, and one of us will take a look at it. We are in the process of doing a minor update to our second edition, and I don't have a due date or like a delivery date yet, but we are hearing from everyone and addressing any erratas that we have.
All right.
Do you mind if I come in?
Oh, please do, Simon. Absolutely, yeah. We were supposed to call you in, I guess, but sorry.
That might have been me, actually. I don't know. I was going to say, what does errata stand for? Like, for those people that are not English speaking, I mean, is there like an easy explanation? Errors and admissions?
Yeah, if you find a bug in the code, or you find an edit, or the words are wrong, or don't make sense, or need some clarification, you just put that in there. It's basically, if you find an error, let us know, and you want to put the link back up.
Hang on. You're rushing me. There we go. It is actually the chat. It is in the Google chat. You can click on the link in the Google chat, and it will take you there.
And I'll just point out, Simon, that it comes from it's an Old English word that comes from the Latin. And
did you just Google that? You just Googled that. That's what that was.
And in fact, actually, one of the interesting things is errata is the singular. The plural is erratum. Or maybe
yeah. Now you're showing off.
Yeah. Right? There you go.
Kevin,
and one other thing before we jump in on the questions, we got a bunch of good questions here I've seen coming up. But the one thing I kind of wanted to point out, we normally would do a little bit of a dog and pony show for you, but I do want to point out the fact that we're giving, we're producing all this content for free, but it's not, it takes our time and it takes effort to do this, and so we do have a Patreon. So I'm hoping, Simon, perfect. It's up there. That's great. And normally, I'm sure we'll be back next week with telling you a little more about what all it's about. But that's just there. If you'd like to help support us, that would be great. We'd appreciate it.
I'll drop that in the chat if anyone wants to click on it, and hopefully we can rustle up a few more people for our private streams and various other things. Again, it's all just anything you can help goes towards the costs of running things and everything else. We're not here to try and make any profit or money or anything like that.
It's not to make Simon rich.
Right back into the community.
Yeah, the expectation is not we're thousands and thousands of dollars. It's like whatever you can do.
So I'm trying to find these time codes. Chopper. Where are we? So we have some questions, and I'll see if I can get up the first one.
Okay.
That was from the last section, sorry. But is there a way to fix all warnings in Dart Fix Apply? Do you know what? I've always wanted that, and I haven't gone looking for the answer. So Dart Fix -- help and see what it tells you, I guess. Does anyone know?
Not
really. No, I've just used the Dart analysis thing and just clicked on them and changed them all.
Yeah, there is.
Yeah.
What you can do, I do know in IntelliJ when I use it, is that once you get one of the files, if you have a file open, so if you open up any one of the files that have an error in, you can right click on it in the analysis window and say fix all. And it'll fix all.
Really?
Yes.
Thank you. You forgot to show me that.
It won't give you that option if the file's not open. Which is, I don't know, there must be some if condition somewhere in the IntelliJ code that's doing that. But yeah, as long as you have the files open, it will give you the option to say fix all normally. Right, in that file, of course. You can also do a little tip for anyone else using IntelliJ. You can right click on your lib folder and choose to Dart format everything in your lib folder. And you can also do optimize imports, and that will optimize all of the imports in your entire project as well. So, if that helps.
Okay.
We need a Simon's tips and
like a magic 8 ball. Just shake me and then I'll give you an answer.
Hey, I have a magic 8 ball app. Maybe we could do that.
Just record little Flutter sort of haikus or something, and then just shake it.
I'm just thinking this is like a huge game of Simon Says.
Oh, I
Let's do this. Esra, go for it.
Okay. We have a Sally's question here. I have zero background about application development, and I'm honestly lost in Flutter that I feel so stupid. There is so many things. Any advice about how to start learning Flutter in the right way?
You're not stupid. Don't think that.
So, I mean, I'm assuming, so this was that they've got no background in programming?
That's what it looks like, yeah. And I, because you're coming from that far away, I think part of the answer has to do with you have to decide what it is you want to do. You know, are you wanting to work on the UIs? That's probably one of the the easier things because you see what you get kind of thing. Or once you start solving problems and stuff, then you have to start thinking a little more like a programmer. And so if you're coming with no application development, you have development experience, and that's also a good thing you can do. But if you're coming at it from no programming experience at all, then I would start with, if you start working with UI and playing around with hot reload and stuff like that, you'll start seeing the changes as you make them. And it'll hopefully start helping you think about things like that.
There is also, I think we asked Kevin. Oh, did he close the tab? It's back now. So I think like as long as you've got a target, right? So as long as you've got something you're aiming for, you can work towards that, right? For like you maybe see like lots of coaches online. Oh, they're doing off here, doing all these other things, and suddenly it comes together in what they're building, right? That's because they've got the experience and the insights to fall back on what they should start with first. But if you come out from the other side of you, do the UI, go, oh, I need to do this next. How do I do that? Go looking for the answer for that thing, and slowly you kind of build up that knowledge about how to do things. And then when it comes to doing that next time, like how do I go to the next screen? We don't need to go looking because you already know. So you just go ahead and sort of put that in. So yeah, I'd say that's one thing. I was talking about this the other day. London App Brewery have a series of courses that you can do. I'll put the link in the chat. They actually have a free course right now for beginners, Introduction to Flutter Development Using Dart by Angela Yu. And then they've also got a complete Flutter Development Bootcamp for 2021, and that's $12. So, you can't.
And is that on their website or is that linked to Udemy? Because they're also on Udemy.
Is on their website, I think.
Okay.
Yeah.
The princely sum of $12. Yeah.
I mean, you can't really go wrong for that, can you? I mean, it's worth it.
That's how I learned. I learned through Angela taught me Flutter. That's where I started.
I did too, actually.
No, there you go. You got 2 gold stars right here. Go
before you had Flutter Apprentice, right?
And what's really nice about that is, I mean, our book's great. Please don't interpret what I'm saying as it's not designed for someone who doesn't know anything about programming. You might be able to get it. It just depends. But the App Brewery course, the way Angela goes through it, it's written or developed for people who also don't have any development. So if you don't know the first thing about an if-then statement, don't worry about it. She shows you with train tracks. I loved her analogy. Even as a programmer, I still watched the whole thing. And I didn't know you had started with that, Kevin. Yeah, it's a great place to start too. And Black Friday sales are going on.
Yeah.
Or just programming in general, I would think that Ray Wenderlich has more than a few possible.
We totally do. Yes. And it's not just
subscription with everything or specific books even.
Yeah. And there's the articles. But yes, thank you for encouraging people. Yes, please buy our book. That would be awesome. Kevin and I would greatly appreciate it. And again, I want to thank Google for making it available for everyone until January 6th. Oh my goodness, I'm sorry. Stop.
All right, before we go to the next question, I just have to jump in and say I've got more obligations. I'm gonna have to run, but I will see everybody next week.
So long.
Thank you, Danielle.
Nice having you.
I will see you all next week. Back to
Happy Thanksgiving, Danielle.
Yes,
Happy Thanksgiving. Happy Thanksgiving, everybody out there, whether you celebrate or not. I'll be thinking fondly about all of you. So
thank you.
Okay. Bye.
So I'll just going to dive straight into the next question because I've completely forgotten what the last question was. How to link Socket.io. Sorry, I'm overreading you.
You can also go for it. So
DMA asked, how to link Socket.io or WebSockets with streams, I guess. Or does it mean stream the company, or does he mean as in streams in the app? I think streams in the app because that's what the last video was about. So we'll go with that. There is actually WebSockets built into Dart's libraries. Dart.io actually has support for WebSockets built in as part of its HTTP package. It's a bit hard to navigate, and it has a different mechanism for doing streams. However, this package, which I'll put in the chat and I'll bring it up on a banner, is made by the Dart team WebSocket channel. And that they basically lets you connect to a WebSocket and have a stream that you can attach to. So it literally does what you're asking. WebSockets and streams. Smush. So yes, this package right here. They actually used this, I believe, for the debug channel, I think it was, or one of these for the debug channel for the when you're doing Flutter development. Anyway. Oh, sorry. Did anyone else want to add anything to the question? I think I kind of answered it. Sorry.
Okay.
Yeah. So if you're doing a little, I'll just add a little thing. Shelf there's a package called Shelf. So if you're doing the server side for WebSockets in Dart, which you can do, there's a package called Shelf, and there's also another package, Shelf WebSocket, and that puts the two things together. So you can do WebSockets within Dart on the server side, and then you can use that package I just mentioned on the client side, and you have live data flowing back and forth between your apps and the server, and it's all cool and awesome and have fun. Right. Do we have another question? That's a good question. Zipping through these. Let's go for a few forward here, I think. People missing their cues. Here we go.
Okay, we have a question about Stream Builder performance. So Eduardo asks, is there any big performance issues for devices if I use Streams or Stream Builder instead of Value Notifier or Value Listenable Builder?
Anyone else? I'm answering all these questions. I don't want to really just shove in there. So
I could be wrong on this, but it seems like to me like they perform two different things. Value notifiers in that for just like one item, where streams are for streams of item. Is that right?
Yeah. I mean, to be honest, it notifies when the value changes, and that's essentially what a stream does, right? Like you pass new data in, and then all the listeners get notified. Here's new data, right?
Right.
I think the difference is that streams offer more flexibility, particularly for this purpose. You can transform your data as it passes through the stream. Only pass on the value if this thing has this flag of true, or or is it not null, or does this field that, or does it have this enum set? You can define on what I think. I can't remember what Craig just mentioned in the video, which was like a pipeline, like this conveyor belt approach. Yeah, you're building up the pipeline, and then you're putting the data through it, and that's what streams gives you, which gives you a lot of flexibility, and then you can kind of almost branch off from that pipeline. You can have listeners at any point. You can do lots of complex and wonderful things. Where value notifying value listener is just that individual listener. There's no performance difference, vice versa, really. I mean, for an individual hit, you're going to be doing the same thing if you're just listening to a stream that does nothing, right? Yeah. I mean, to be honest, they're two different things, right? Like streams for constantly delivering, value is for you're just sort of updating a value. Very semantically different. I'll let you guys pick up this one for a second whilst I find another question because this. Sorry.
Okay. Tasir asks, which backend is good for Flutter for a large application?
Does he mean backend of app or backend as in server?
That's what I was kind of wondering, because I mean, when I think of backend, I think of server work. So are they talking about writing the server maybe in Dart or something? But again, Flutter can work with any backend. It doesn't matter really what the backend is written in. You can just use REST APIs and so forth to work with it.
In fact,
and you can. Go ahead. Nope. I was just going to say, in Dart, you can have it on a server and have use it too.
Yeah.
Simon taught me that.
There's actually like
earlier this year.
There's libraries for Postgres and for SQL, different things and everything else. So you can do all your APIs and everything else. And I keep mentioning Shelf, written by Kevin Moore, but like, and a few others from the Dart team. But like, yeah, there's loads of stuff there. But back end of an app for a large app, I mean, that's again, just pick your app architecture, state management. There's no one solution. They're all good for big or small. I mean, what scales well for your application, really? I can't think of one thing that would say. I know for a fact, and I'll mention this now, it depends on how you use it, mind you, but I've heard back from some people that have been Redux for large applications, and they've gone to a situation where they end up doing a lot of rebuilding, a lot of things that happen in the back end every time they change their Redux app state, sort of global class thing. So that ended up giving them a performance problem. But I mean, you can actually break it down to smaller units, and it's more complicated. But pick the one up. Pick your poison, as they say, right? Whichever one's gonna kill you the slowest. Right.
Okay. Thank you. Then Jeff asks, please explain the T construct and contrast that with dynamic and object types. So we are actually looking for T versus dynamic.
They're totally different things. So contrast that with dynamic. So object is the base type of every object, right? But it's a strong type, right? Dynamic is a placeholder for any type, right? But it's at runtime anytime, right? So there's no anytime you access a dynamic, it has to be type checked. There's extra processes involved to make sure it doesn't crash the app, right? And where T is a template, or T stands for template or type. It can be any letter, believe it or not. Just T is very common. And all that declares is, I want a type here when you declare your class. So you put my class T, right? And then wherever you put T inside that class, it's going to supplement that type when you construct that class. And in doing so, you have strong typing in your class. And it's made your code flexible. So the idea is that that T can be any type you want, and it will still be strongly typed at runtime. That does impose certain things. So if you want to call a function on T, then you should normally do a abstract class that has that method, and then you say T extends that interface that you just did get the abstract class. And that means that any time you use any class you put where T is has to implement that interface. And that ensures that they all have the method, basically. It's a bit different in other languages. Like you can get away, because other languages are prototyped. That's like JavaScript and Python and a few other ones. You can just put any type you want and it'll work as long as it's got the method, right? Like, interesting enough, you can get away with this in Dart, but it's not the same. So if you try to call a method that doesn't exist, it will call a global method on the base object called no such method. And this is how mocking works in tests. But it's very slow because it has to convert all the parameters into an invocation object. They have to be put through a symbol lookup. I won't go through it. Pass to your no such method, and then you can make a choice of, if the method that was being called is this, then do that. It's no good for runtime. It's like reflection. It's just not a good idea. Also, if you obfuscate your app, then those symbols are obfuscated as well. Doesn't really work. So stay away from no such method. It's great for testing though. Short answer. Sorry, I'll rattle on.
One important thing about that is called generics. So
yes, sorry, yeah. That's a generic type. There you go. What else do we have here?
I guess we have one more question from Jeff.
We have a couple more questions. I'm just going to go for the last few quickly.
Okay.
I feel like I should be seeing one here that, this one.
Okay. We are going with Eduardo's question. While using many streams with block, what's the best strategy to use nested stream builders?
What's the best strategy to use nested stream builders? Okay, I can tell you exactly what I'd say, and that is you need to make sure you have your initial data set. So if you put any feature builder or stream builder, in fact, Randall Schwartz, who's normally here, if you go find his YouTube channel, he did a great video. Me and him worked on a bit of content, and he did a video and showed it off on his recording. But if you put a feature builder or two stream builders inside each other, or many, doesn't matter how many times you nest it, or future builders and stream builders again nested, if you don't specify initial data, when it rebuilds, you're getting an initial state of blank, which means you might get a loading spinner for one frame or something like that. Even worse is when you put, a lot of people put the item that constructs their stream, like a getter that constructs the stream, or a getter or something that returns a future, like an async method, putting that as your parameter to stream builders or future builders means that every time the build method is called, it creates a new feature, it creates a new stream, losing the state of the old one. So you lose that initial state, and it has to load the initial value again. So the best strategy, just using stream builders in general, nested or not, is to fetch your stream or your future in your init state of your class, and then provide that local variable to your builder, and that way it will survive the rebuild. So if your build method is called multiple times, it continues with the same future, and you'll have the same async snapshot, which is critical because then you won't lose the data. You can, even if you record it again, if you have an initial data, you're always guaranteed to have that initial state, and you won't have to proceed through the first initial steps of connecting and loading your stream. Yeah, sorry, went on for a bit. I see it all the time. Just a bit of a rant.
Okay, this was awesome. Actually, it was also super critical to not have it, create it again and again and not lose the value. This was, I think, one of the best advice. Cool. Okay. Maybe we can go for the next one. What do you think?
Anyone else want to? Sorry, I ran on. I don't want to answer all the questions. I honestly don't, but I always have something to say.
Okay, Richard asks, is there a difference in marking a function as async rather than returning a feature.value?
Now, correct me if I'm wrong, but my understanding is if you mark a function as async, you have to return a feature, right? If you're returning the value.
Yes.
Well, you don't have to, not inside the method, but by default, the return parameter is a future. Right. By declaring it as async, it generates a future and essentially runs that code in that future, right? In that asynchronous coroutine. When you have a function that returns a future and then returns a future.value, it's essentially, it's not the same thing because you're not constructing the future. It's the function that constructs the future, not the invocation of the function that constructs the future. Very, very similar. And honestly, most of the time you want to use async on your methods because it means you can just use await, right? Like without any fuss. There's a time. So I don't know if people have seen this, but when you're dealing with futures, you've got the async and await, and then you've got the then function call, and you can do catch error and when complete on a future. And one is this sort of the setup of the pipeline, the synchronous one, very much like streams, and the other one is declarative. So using async and await is very declarative. It's easy to read. I prefer that mechanism over the other one, but there's reasons to use both. Something to avoid. Well, something I did. It's kind of a little bit of a story. If you have a future, a method that's returning a future that calls another method that returns a future, you'll be tempted to not mark it as async and return the other method's result. Now you go to yourself, okay, I've optimized because now it doesn't have to create another future. This is correct. You have done that. But what happens also is that you've lost the call chain because you return that feature, when that feature is running, it doesn't know that that middle function was called because it's no longer in the call chain anymore. So when you see a stack trace, you lose them, right? So you won't see the entire function call chain because it's not in the process when creating the future, when the running features execute asynchronously. Anyway, the point here being that you should always mark your functions as async and always await. The cost of having something waiting, you would have to get a hell of a lot of asynchronous methods to really stall the main loop pipeline of Dart. Like, I've never seen it happen, put it that way, and I'm doing it a lot. So I'm sure you could, right? Spin up 10,000 coroutines. I'm sure you'll start seeing some funny issues, right? But for the most part, most applications, you're not going to see any problem with using async all the time everywhere. Anyway, did I skip one? I think I skipped one.
Yes. Now we can get our last two questions, and we are kind of over time. So,
yeah.
Okay. The skipped question, Jeff's second question here. If you have different containers or tables, would you have different repositories for each one, or would you have one that's abstract that would work for all of them?
If you had different containers or tables, would you have different repositories for each? The one that's, would you have one that's abstract?
So are we talking about database stuff, or?
I have no idea. I don't get the question. Sorry, Jeff. Yeah. I can't place containers and tables in the context of what you're asking. If you can rephrase it, ask quickly because we might get to it. Let's jump on to the next one.
Okay.
What was the other one?
That was interesting. I thought I misread it because I didn't understand.
No, I think that was. I didn't get it either. Like, it's like when everyone on the stream turns their head like a dog, like what?
Yes. Now we have our last question from Richard, and he's asking: do you all recommend learning how to use the block library before moving to Flutter block and freeze?
The block library before, I mean. How
to use block library before moving to Flutter block?
Okay, so I think this goes on about what Craig was doing in stream. Craig implemented block pattern himself before going to use the Flutter block package itself and freezed. And that was just to show you how it works under the hood to get you understanding like streams. So yes, I think understanding, not necessarily implementing the block pattern yourself. I mean, I've done it multiple times, and it gives you some freedom because you're not locked into how Flutter block says you should do it. You should always have an event. You should always have, you should always have state that and emit events and other way around, whatever it is. Anyway, the point here being that yes, it can be helpful, but if you're just trying to do the block pattern and use that as your state management, use Flutter block and freeze. Go for it. I don't think there's.
Well, there is also a Flutter block and block libraries are both built by the same people, but I'm trying to figure out what the difference is. Obviously, Flutter block is for Flutter specifically.
Yeah, it gives you widgets. So it gives you like block provider and a few other widgets that help you navigate and consume blocks in the front end, whereas the block pattern itself is platform agnostic, right? You can use that in just pure Dart, right? Like it's a state management. It's nothing to do with UI. I honestly, Flutter block uses blocks, so there's no. I don't think he means that. I think it's what Craig was talking about.
I mean, I would assume you just include Flutter block and you'd get block with it.
Yeah, you do. It's a dependency. Yeah. Right. Quickly to see if
Jeff responded.
He did. Quick. Further question.
At 18. There you go.
Craig's data repository contract. I must have missed that.
It was about if you have different containers and tables, would you have different repositories for each?
Oh, I see what you mean. So like you got different outputs on the screen, would you have different repositories? So there's a repository pattern, not as in code repository, right? So the idea that you've got like a manager for your data in the back end of your app, and if you've got different sets of data, would use. I mean, honestly, as long as you're consistent, that's all that matters. So if you've got two tightly coupled data models, and then you want to use them in one sort of manager / repository in the back end of your app, then sure. I mean, that works as equally as much as doing them independently and having them talk to each other. I don't think there's any one right answer, but if you're going to do this pattern across your application, make sure it's consistent across your application, and don't do it differently everywhere. And then you'll go, how is this one working? Why is this one different from that one? You'll be asked, you'll be scratching your head, especially when you come back to looking at it after a while. So, yeah, I don't think there's any one answer. Which I want to. You could, I mean, I think the second part of that question is more about like, you could create an underlying abstract class that all of them implement, something like that. And sure, you could do that, I guess. Hopefully that helps. Sorry, Jeff. It's a bit last minute on the stream. Hopefully that got you somewhere. Right. I think that's about it. I could probably stick around for a couple more minutes if there's a couple more questions coming in. If anyone else has to leave, I don't know. It's just a shame we didn't get to any like general Flutter questions. There's a couple in there. Anyway.
Directly to you.
I guess it's directly to me. There's a cookbook section with effects in the Flutter website now. I wrote some of those. Yeah, go check that out. That'll give you some ideas about how to use animations. But the best thing I would suggest if you want to learn is to start playing around with the animations framework, start doing something. Don't try and aim for the end product that you're trying to build. And aim say, I go look at some Dribble or something. There's these design websites. One's called Dribble with 3 R's. Go look at one of the little app examples on fancy animation the designer's made and go, how do I do that in Flutter and tackle that, right? As a quick demo, that's throwaway code. And just the act of trying to do that, you'll learn so much about the animation framework. That's as best as I could suggest. I don't know of any particular learning materials out there for advanced animations. I've done a few various examples on my gists and I tweet them out. So if you go to scroll back through the Twitter history, I'm sure you can find it. I always hashtag Flutter tips. So if you search for that on Twitter, you'll find them probably. Best I can suggest.
Okay.
I think that's it. I think. Anything else come in?
Just Majid saying hello.
Hi, Majid.
Hi, Majid.
The Flutter Viking himself.
Yes.
Oh, look, that equity. It doesn't cache, but you can just download your video and play a downloaded video file. Therefore, you've cached it. There you go. Problem solved. All right, that's it.
All right.
Oh, there's another one. Yeah, I was just going to say there's that one.
Can you advise where I can host my database Postgres to use in my application? AWS is a bit expensive for me. Believe it or not, AWS and Google Cloud, when they create a cloud SQL instance, is you can just run it on the very bottom level of their platform. So you can just spin it right down to like the one virtual CPU and like 512 meg of memory. It might be rubbish, right? But then you can at least develop with it and it'll be like $2 a month, right? Or $3. I think it's about $3.75 a month or something for the lowest end Google Cloud Platform server or something like that. But yeah, you can just host it on your local computer. That's another thing, right? Nothing stops you from installing Postgres on your local computer and connecting to your IP address of your local machine, 192.168 from your emulator, from your real device. There's all sorts of ways of doing it. But yeah, if you want to host it online, then yeah, you're going to need to find a provider, any provider that can host a server for you, and then you install Postgres or other database provider or anything else, right?
Okay, so I'm really embarrassed about the whole animations thing. I didn't speak up. We have articles on raywenderlich.com regarding animations, both like the screen animations as well as there's 2 new ones for 2D games.
Yeah. So great. Check out that on the website. In fact, go get your subscription right now on the let's trying to push that in there. There you go.
Yes.
On the Black Friday sale right now, you get it a lot cheaper and you can get access to all that material or something like that.
Yep. You can get access to all of the material, the books, all the video courses. The articles are free without the subscription, but subscribe. Right, Kevin?
Cool. So
Okay.
that link will be in the chat. And I think that's it from all of us.
Yes.
Yeah.
It was an awesome another Q&A session. And thank you, Kevin, again, joining with us. That was an awesome, awesome to have you here. So I just want to add one more thing here. So please do not forget to do your homework for the next week, which is about state management.
Yeah.
So let's kick off next week. Anyone wants to add something?
Chapter 13. Go read that. And I'm sure you'll find lots of controversial material online about state management, which we can talk about next week. So
yeah, we don't want to go down part of that rabbit hole. Regarding the chapter,
yes,
read it twice. Don't go through it once and then just go, what?
If once wasn't enough, you need to read it twice.
As the tech editor for it, Kevin will attest, I went through it 3 times. Yes, there are still mistakes. You can report them on our errata, but go through it and it will help. You did it.
We will have hundreds of questions next week about state management. Get ready for it.
Get ready for bumper filled time. Right. We'll see you all next week.
See you all next week. Bye.
Bye.